I am interested in knowing what it is like to learn to program in Forth or with R3 as the first language. We are going to use graphics that are already made. We have these image files. They are different frames of a drawing that, if they alternate, give the sensation of animation. We create an empty text file and copy the name of the graphic files to bring it up. We put the full location from the place where R3 is executed. Now we are going to expand these words that the machine knows with others already built. For this, if the word begins with a caret, it will include these definitions. We will use sprites, interaction, and image loading. The place of the beginning of the program is the word colon only. The prefix single quote will indicate an address, and the word unshow will use that address to execute the word continuously. With the prefix colon, we can define other words. Here we are going to load the image files with the player's ship. Data or variables are defined with the numeral prefix. And for the game, the following orders will be repeated. Clean the screen, show the first frame at position 100 in pixels with a graphic player, and we will also check if we touch the escape key to exit. We are going to use a sprite sheet. I call R3 to execute this code and the ship appears on the screen. I'm going to add the enemy's drawings, which is also a sequence of images, and explosions. Each of these images has to be loaded into memory, referencing it with the defined variables. I suspect that the simplicity and flexibility of the language has to be a benefit to whoever is learning to program. Computers only know the numbers. The rest of what we see are representations. Deep down everything is a number, and these have only two functions, count or locate. In the case of graphics, they will be loaded into memory, and the variable will contain the location where these graphics are. At the beginning, the language knows about 140 words, and they refer to arithmetics, logics, move numbers from one place to another, choose or repeat operations, and some other things. The text that I am going to write will be understood by the machine in some way, and it will be executed, action, definitions, and with a semicolon. I am going to indicate that we are going to use 2 megabytes of memory necessary to save these graphics. This is the maximum amount of memory that it will get to the operating system. If we replace the position of the sprite with the coordinates of the mouse, what we will obtain is a ship cursor. We are going to factor the code, creating a new word. This will make a program easier to understand because it divides the code into more manageable parts. Instead of using the first drawing, we are going to take the milliseconds of the system, divide by 128 with a shift to slow it down, and take only the number from 0 to 4 with a AND mask. This produces the animation that is in the sequence of images. We are going to define a variable as a position on the screen using fixed point numbers. This allows us to use decimals. We will also use another variable, such as the speed of the ship. Before drawing the player, we increase the position with his speed, and we set the minimum and maximum as the limits of the screen. We use this variable as the y position of the ship on the screen, converting it to an integer. The keys will modify the speed variable, and this speed will be added to the position. When the scroll keys are released, the speed returns to 0. Here we see how we can move the ship with the keys. Let's add the enemy. For this, we will save the position in X and Y. We will also make a word that will draw it on the screen by cycling the animation. The coordinates are in a fixed point, and we need to convert them to integers. We add this word to the main loop, and we can see the enemy ship. We put that when it comes out on the screen, and it comes back as a new UFO. chooses a number at random and limits it to the screen size in Y, and puts it on the far right on the screen in X. We are also going to subtract the X coordinate of the UFO so that it moves to the left. Here's wrong. Instead of height on the screen, we must put the width. We're going to add the bullet, and we'll use integers for the position now. We use the X position as an indication that there is a shot or not. When it is at 0, it does nothing and finishes. Add 7 pixels. This is the speed of the bullet. If the bullet leaves the screen, it disappears. The drawing color is the ink variable that we put in white. Then we draw a line in XB, YB up to XB plus 10 and YB. Here an error occurred, that is, a word not found is more than written on line 55. We correct it. We add the space key to activate the trigger. And we do it only if there's no bullet, assigning the Y to the same position of the ship and the X to the beginning of the ship. There, we can shoot. Let's see if the shot hits the alien. For this, we calculate the distance between the center of the alien and the bullet in pixels, obtaining the differences in X and Y and using a function that calculates the distance quickly. If we see that it is greater than 20 pixels, end this word. Otherwise, I remove the bullet and put a new UFO. Let's now test the impact of the bullet on the alien. Well, the only thing missing is the explosion that's going to happen right now. We define the explosion assigning variables for this drawing, in X and in Y and in the number of frames, but it's 16 per animation. We define the variables and now the drawing of the explosion. Will happen while it's active. XS will be the frame number with the saved position, and the table will advance little by little, that's why the decimal number. When I get to the last painting and a little more, I'll remove the explosion. It does not show the explosion. It's because the word needs to be added in the main loop.